Good morning, everyone. In this session, we will be studying about pipelining. We all know that pipelining is a concept of parallel processing. The main purpose behind using this pipelining is to improve the performance of our computer. Okay, we will need to improve. Now, performance of the computer include in two different ways. One, either you change the hardware of the computer, that is, move to higher processors, advanced processors, okay, change the processor of the computer. And second way is, without replacing the hardware, we'll just be using the existing hardware and arranging it in such a way that it increases the performance. Okay, arranging the existing hardware in such a way that it increases the performance of computer. So here, pipelining is nothing but arrangement of hardware components in such a way that it increases the performance of the computer. Now, how can the performance be increased? In case of pipelining, multiple instructions carry out simultaneously. In the pipeline, we know that pipeline is what? This is somewhat a pipeline. Your instructions are there here in it, and all the instructions are executing simultaneously. The arrangement of it is you divide your task into different segments. Okay, this is my segment one, this is segment two, and here you have registers. The output of one segment is given to another register. From the register, the input goes to the next segment. Okay, so the arrangement is carried out in such a way, this looks like a pipeline. Okay, here you have register 1, register 2. This is how the hardware is arranged. Let us see a more practical example. If we talk about a non-pipeline architecture, in non-pipeline architecture, until one process completes, the other process cannot start. Whereas in pipeline architecture, if one process is working in a particular stage, the other process can work in some other stage simultaneously. Let us take an example of McDonald's. Okay, you all must have visited McDonald's drive-thru. Suppose I want to purchase something from this McDonald's drive-thru. I have, suppose, three windows here. Window 1, window 2, and window 3. At window 1, I'll place my order. At window 2, I'll carry out my payment. And at window 3, I will receive my order. Okay? Now, suppose there are three cars waiting here in queue. You have car 1, car 2, car 3. Now, suppose car 1 goes inside the pipeline. Car 1 is ordering here. I have different time cycles. Okay, at time cycle T1, what happens? Car 1 is in order phase. Then at time cycle T2, what will happen? Car 1 will go over here to the payment wise, whereas car 2 will go to the order phase. Okay, so at time 2, what will happen? Car 2 is in ordering phase. Car 1 is going to the payment phase. In time cycle 3, car 1 will reach over here, that is receiving phase. Car 2 will reach to payment phase, and car 3 can enter inside the pipeline. So car 3 will go to the order phase. It's not clear? So now what will happen? After 3 clock cycles, car 1 will receive its order. After that, if I talk about the 4th clock cycle, what would happen? Car 2 will receive the order. Car 3 will go into the payment stage. At time cycle T5, car 3 will receive its order. So if you look at this arrangement, after 5 clock cycles, all the three cars, car 1, car 2 and car 3, receive their orders. But if I do not have three separate windows, what will happen in this case? Order, payment, receive. Car 1 will go inside until it completes its order, payment and receive 3 clock cycles. Car 2 cannot enter over here. Okay, so car 1 will take 3 clock cycles to complete. Once car 1 moves out, car 2 gets its chance, so it will again take 3 clock cycles to complete. Again, after car 2 receives its order, car 3 goes inside and it will again take 3 clock cycles to complete. So if you do not divide your task into different segments, you are taking 9 clock cycles to complete. Whereas, if you had divided your task into 3 different segments, how much time did I take? 5 clock cycles. So, this is the example of pipelined architecture, whereas this is the example of non-pipelined architecture. Understood? So, if you look at our pipeline architecture, car 1 will take that much time that it will take time as per the number of segments that you have. If you had 3 segments, car 1 will take 3 clock cycles to complete. And after that, after 3 clock cycles, at every clock cycle, you get output of the next car. Look over here. After 3 clock cycles, हर एक clock cycle में आपको एक एक कार का output मिलता जा रहा है, right? So here, if I want to calculate the number of clock cycles required for n cars to complete, how much time will I need? जितने segments, उतना first car time लेगी. And then n minus 1. Suppose I have 3 cars, so after that in 2 clock cycles, all the cars will be out. Okay, so here 2. So total 5. So if you have n tasks to process, n tasks in a k segment pipeline, how much clock cycles will you need? N for the first car, K for the first car, and then for remaining, at each and every clock cycle, the next car will be out. So, jitne remaining hai, how many cars are remaining? N minus 1. So, what would be the formula to calculate the clock cycle? K plus N minus 1. Okay, so in the previous example, McDonald's one, we had how many segments? 3 segments. How many cars? 3 cars. So total how many clock cycles would we need? 3 plus 2, which is 5. So suppose I have 5 cars. Again 3 segments. Tell me how many clock cycles would be needed? 5 cars, 3 segments. So 3 plus 5 minus 1. That is 7 clock cycles. Is it easy? So in 7 clock cycles, all the tasks should be completed. Now, so this was the best example, practical example, which we can, through which we can understand the concept of pipeline. Okay, now how to use it in the questions given to you. Suppose you are asked to execute a particular equation using pipelining. Okay, so now we know that if I want to execute anything using pipelining, the main concept of pipelining is what? You divide your task into different segments. Suppose this is the equation given to you. AI into BI plus CI. Okay, now here I know that if I want to execute this equation, I is 1 to 7. Okay, so I need to carry out how many tasks? I need to carry out n tasks. इतना मुझे पता है. Okay, how many clock cycles would be required for doing this? That I know that if I know the value of n, I also should be knowing the value of k. Once I get to know the value of k, I'll be able to identify how many segments, now how many clock cycles will be required. So to identify k, I need to first divide this thing into different segments. Okay, so let us identify the different segments over here. Segment 1, we know that a pipeline architecture is divided in such a way that you have segments and you have registers. Segment, registers. So for carrying out some task, I'll first need to load my data into a register. Okay, so in segment 1, what we will do is we'll load the content of AI and BI to R1 and R2 respectively. Okay, because I need to carry out this multiplication first. Okay, in segment 2, what will we do? We'll perform multiplication of R1 and R2. And simultaneously, can I load the value of C into R3? Sorry, R4? Okay, so now my R3 and R4 are also ready. In the first segment, R1, R2 were ready. In the second segment, we loaded R3 with R1 into R2 and C to R4. And in the final segment, that is segment 3, what we will do is R5 is equal to R3 plus R4. This would become my R3 and this is R4. So final answer would be R3 plus R4. So how many segments will we divide this equation into? 3 segments. How many tasks do we need to do? 7. So can you tell me how many clock cycles will be required? 3 plus 7 minus 1. Right? So total 9 clock cycles will be required. Itna done? Understood. Okay, fine. Now let us move ahead. What you may be asked in exam is, this is the equation given. You represent this using a pipeline. Okay. So first thing, how to represent it using a pipeline? We will first specify what was the first task that we did? We loaded AI and BI to some registers because we know that every segment is separated by a register. Okay, so R1, R2. After that, we place this R1 and R2 to a multiplier. This multiplier's value was stored to R3. Okay. Similarly, during this, when we loaded R3 at the same time, we placed the content of Ci to R4. And so this is my segment 1. This is segment 2. And in final segment, what did we do? We placed the value of R3 and R4 to an adder and the value got stored to R5. Okay, so this is my segment 3. So this is the pipeline configuration. Okay, now you may be asked to show the content of registers. We know that total 9 time cycles are required. Okay, you may be asked to show the content of register in pipeline during each clock cycle. So let us quickly see that how to represent it. Clock cycle, we know that. How many clock cycles do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll complete it afterwards. Okay. How many segments we have? Segment 1, segment 2, segment 3. In segment 1, we are using R1 and R2 register. In segment 2, we are using R3 and R4. And in segment 3, we are using R5. Now let us show what are the content of registers at different clock cycles. In the first clock cycle, what happened? In segment 1, A1 and B1 got loaded to R1 and R2. In second clock cycle, what happened? In R3, A1 into B1 took place and in R4 we loaded C1. But simultaneously clock 2, what we can do is A2 B2 pipeline के अंदर आ गए. Did you understand? Let us see the third clock cycle. In third clock cycle, what will happen? A1, B1, C1 will transfer to R5. So in R5, what do we have? A1 into B1 plus C1. Where will A2 B2 go? A2 B2 will go to segment 2. So A2 into B2 here and C2 over here. And what will come in segment 1? A3 B3 will be ready now. Chalo, move to the fourth clock cycle. A4 B4 will enter here. A3 B3 will transfer here. And A2 B2 wala output ready. Okay. Similarly, 6, 7, 8, 9. Here A5 B5, A6 B6, A7 B7. We have 7 tasks. Okay. So here like this. Now here A4 into B4, C4. Here we will get the answer of A3 B3, C3. This 5 will come here. So A5 B5, C5. This will come here. A4 plus B4, C4. Did you understand? These are the different clock cycles. इस clock cycle में A6 B6 आगे बढ़ेगा. In the segment 2. And A5 B5 will get the answer is ready for A5 B5. Okay. And finally, in 8th clock cycle, A7 B7 will be here. A6 B6 वाला आंसर आ जाएगा. And in the last clock cycle, that is ninth clock cycle, this answer will get. So all the tasks got completed in 9 clock cycles. Okay, this we knew the formula and hence we could make out कि पहले से 9 clock cycle है. But even if you don't know the formula, if you carry out this process, the first segment clock cycle run में इधर होगी first here and third clock cycle it will come over here. Similarly, second. If you complete this table, you will understand that totally you will need 9 clock cycles to get the output of all the 7 different tasks. Okay, so for AI into DI plus CI for I ranging from 1 to 7, I took 9 clock cycles to complete the answer of all. Okay, so what is this? To show the content of registers, during each clock cycle, we represent it using this type of table. Okay, and the next thing which can be asked over here in this type of question is to represent the same thing using space-time diagram. Okay, how to represent it using space-time diagram? You represent the segment on the vertical line, segment 1, segment 2, segment 3. And on the horizontal line, you specify the time cycles 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these are the clock cycles. Now you need to show like this. At clock cycle 1, let me show it to you. Okay, at clock cycle 1, T1 is in segment 1. At T1 is task 1. At clock cycle 2, T1 will go over here and T2 will be in segment 1. At clock cycle 3, T3 will go here, T2 will go to segment 2 and T1 segment 3. Here, at clock, and just a minute, did I make any mistake? Okay, I made a mistake here. Yeah, so T1 will come here. In the clock fourth cycle, T4 will be here, T3 here, T2 here, T5, T4, T3. So look over here. First task took 3 clock cycles to complete. And after that, we are getting the output of next task, T2, T3, T4, T5, T6, T7. So at T7, all my tasks are ready, okay? So this is how you'll be completing it. So this is known as space-time diagram, where on the left-hand side you show the segments, on the horizontal bar you show the clock cycles, and in between you'll be showing the tasks. Okay, the tasks move like this. Segment 1, segment 2, segment 3. Segment 1, 2, 3. Okay, and it's because of this, we are able to complete. Suppose I do not have a pipeline architecture, what will happen? I have 7 tasks, 3 segments. So each task for a non-pipeline architecture will take 7 3 are 21 clock cycles. But the same task we can complete it in 9 clock cycles in a pipeline architecture. Okay. So now for this type of question, whenever any equation is given to you, what you will do is first divide it into segments, calculate the number of clock cycles, draw the pipeline architecture, pipeline configuration, represent the register content during each clock cycle, and design the space-time diagram. Is the concept clear? If I want to calculate the speed up ratio over here, what is speed up ratio? How much time does it take? Speed up of a pipelining is, if I consider the non-pipeline architecture and I consider a pipeline architecture, how much time will it take? So here we are calculating the speed up ratio. For a non-pipeline architecture, over a pipeline architecture. Okay, so if I see how much time did I take to complete non-pipeline task in non-pipeline architecture, जितने task उतना multiply by Tn. Tn is what time taken in non-pipeline architecture. Whereas in pipeline architecture, what we do is We know that A plus N minus 1 is the time required. Okay, and if each clock cycle is of T P time, we say that the ratio is N upon K plus N minus 1 into Tp. Okay, so if you want to calculate the speed up ratio S, it is N upon K plus N minus 1 Tp. For clock non-pipeline architecture, we say that for n tasks, I'll need n clock cycles into Tn. Tn is what? Tn is time required in a non-pipeline architecture. And Pp is what? Time required for one clock cycle in pipeline architecture. We know that we need k plus n minus 1 clock cycles, and hence the speed up ratio is this. Now, suppose you consider this k. Suppose I have n tasks. Okay, and if my tasks are 10,000, this k is negligible compared to n. This k is very, very, very less to n. So can I consider this k to be, can I ignore this k? Right? So if I just ignore this k minus 1 will be ignored because 3 minus 1 is 2, which is very negligible compared to 10,000 lakhs of tasks to be done. So if you want to achieve the maximum speed up ratio, what is maximum speed up ratio? Where I am considering k to be very, very small compared to n. So in this case, k minus 1 is ignored. So it will become ntn upon ntt, which is equal to tn upon tt. So this is the formula for maximum speed up ratio. Understood? First, we calculated the actual formula practical value of speed up ratio. Then we calculated maximum speed up ratio. Is that clear? Next is theoretical value. Okay, theoretically, if we consider Tn equals to KTP, fitness segments into the time required for this. So if you assume that the time it takes to process a task is the same in pipeline and non-pipeline architecture. Okay, if you say that Tn is same as KTP, if the time required for this is assumption. Okay, if you assume that Tn is same as the time required in a pipeline and non-pipeline architecture, then Tn would be KTP. So in this case, theoretically, if you consider the value of speed up ratio, we know that it is Tn upon T2. Okay, so in this case, my Tn is KTP upon T2, which is equal to K. So it is equal to number of speed up ratios theoretically, where we assume that Tn is equal to KTP. Okay, so we identified three formulas. Formula 1 was actual speed up ratio. What was the actual speed up ratio? NTN upon K plus N minus 1 into T. Okay, second formula we studied was maximum speed up ratio, which is equal to Tn upon Tt. When to consider maximum? When K is much, much less than N. And third, we saw the theoretical speed up ratio, where we considered Tn to be same as the time required in non-pipeline architecture to be same as pipeline architecture. So in this case, the value of S is equal to K. So these are the three important formulas which you need to learn when you are studying a pipeline architecture. Fine. So this is all about pipelining basics. Okay. In the next class, we'll be studying three different types of pipeline, that is arithmetic pipeline, instruction pipeline, and risk pipeline.